reproductive health issues, gut concerns like IBS or even GERD. We're starting to see that melatonin can span many different body systems. And I think based on what we're talking about here, one of the common threads or the links might actually be the mitochondria.
Well, hello everyone, Dr. David Perlmutter, and welcome back to the Empowering Neurologist. Certainly, a nutritional supplement, if you want to call it that, that's attracted a lot of attention lately has been melatonin. We've heard it advocated for everything from jet lag to getting a good night's sleep to even helping your immune system if you have COVID. But what's really going on with melatonin? We'd really like to find out, and that's why today we're going to be speaking to my good friend, Dr. Deanna Minich. Let me tell you a little bit more about Deanna. Deanna Minich, MS, PhD, CNS, a certified functional medicine practitioner. She's a nutrition scientist, international lecturer, a teacher, and an author with over 20 years of experience in academia in the food and dietary supplement industries. Throughout the years, she's been active as a functional medicine clinician in clinical trials and in her own practice as well. Over the decades, she has taught virtually thousands of nutrition classes for health coaches, fitness trainers, healthcare practitioners, including programs offered up by the Institute for Functional Medicine. I work with her in the field of nutrition as we're both part of the American College of Nutrition. We support that. In conjunction with her academic degrees and extensive teaching experience at the university level, she is both a fellow and a certified nutrition specialist through a group that I participate in, the American College of Nutrition. So let's sit back and learn all we can about melatonin. Well, Deanna, so great to see you.
Good to be here with you.
And I think back about lecturing with you in Sydney, Australia. How great was that many years ago? And I remember going to an opera at the Opera House. Oh, actually, it was outside. It was a great time. We had a great trip. But anyhow, you just put out this wonderful paper that I think is so important because everybody wants to know about melatonin. I mean, we've been hearing so much about it in terms of jet lag and more recently about boosting immune function, which people are all, deeply invested in these days vis-a-vis many of the infectious issues of our time. But before we jump in, and for our viewers, we're going to post a link to Dr. Minich's wonderful article. Before we jump in, why the interest in melatonin? What got you started?
Well, I'm interested in all things plants. So I've been talking about the rainbow for some time, looking at all the different types of pigments that are in plants. And melatonin became much more popular, I would say, over the pandemic. So I began to look into it. And then I realized that melatonin is actually a growth factor in plants, and it can be what gets those plants to produce phytochemicals. So then I began to think about
Fascinating.
melatonin in the way of it's kind of the mother phytochemical in so many ways. It's ancestral. It's been around for a really long time. It's part of our mitochondria. It just has so many uses. In fact, one of the things that I learned is that it's beyond a hormone. It is really beyond sleep. So that piqued my interest. The connection with plants, that of course is what I'm all about.
Well, I want to let our viewers know that most people have heard of melatonin. Maybe you take it if you're jet lagged or you can't sleep, or we'll talk about those uses. But what you revealed is that this is highly conserved, found in animals. Certainly, we might have expected that, but in plants as well, and that it serves a broad range of functions in the living world. So let's start then. You mentioned phytomelatonin, or you mentioned phytonutrients or phytochemicals. Phytomelatonin, meaning plant melatonin. So plants have melatonin, and it's not helping them get through jet lag. So what's it doing for them? And beyond that, can we benefit from that when we consume those plants?
Short answer is yes, we can benefit from that small amount of phytomelatonin. The amounts in plants, though, are in nanograms, picograms per gram. So it's going to be minute, but it's everywhere. Melatonin is pervasive in the diet. The thing is that in order to replenish the levels that we're losing over time, we need much more than we can get in a plant-based diet even. So I think that that's one of the misconceptions that I realized as I was going through the literature, when I actually started to calculate the numbers of what you would need to eat in order to get back your melatonin, it was looking like thousands of cherries, several hundreds of cups of walnuts. So while it's good that it's in our diet, I don't think that we can rely on that solely.
Well, I was very gratified, although it would take a lot to see that coffee beans were probably the highest, one of the highest foods containing phytomelatonin. But again, the point being that while we eat these plants, the amounts in comparison to what we get produced generally in our bodies, which declines with time, we'll talk about that. They're really pretty much, we shouldn't turn to plants as a reasonable source for melatonin. We make melatonin in our bodies. And I think the teaching has always been that's one of the functions of the pineal gland, this almond shaped gland that lives in the back of the brain. We didn't know much about it, but you reveal in your paper that the enterographene cells, or cells in the intestines, are intimately involved in manufacturing melatonin, and that there's no light dark input in terms of how those cells that are part of our gut are involved in producing melatonin. So what's the contribution of the gut then to making melatonin?
Well, first of all, melatonin is made throughout the body. It's found pervasive in pretty much most cell types. And if we look at organ systems, what we see is that melatonin is made locally in those organ systems and used locally for the purpose of that organelle or that tissue. So there are different kinds of melatonin, and we have different kinds of receptors. So the kind that we think of from the pineal gland is very specific, and that is released in relationship to darkness, which is why melatonin is called the hormone of darkness. And we talk about darkness deficiency, that people aren't getting enough of the darkness that they need in order to stimulate that production from the pineal gland, which then helps to regulate our circadian rhythm. But melatonin has functions beyond the circadian rhythm, which is why we see it produced in so many different cell types. To your question about the gut, what we see is that in the enterochromaffin cells, that the gut can produce melatonin locally, and often it's produced in response to a meal. So there's a postprandial response. And what I can surmise from what is available in the research is that essentially that melatonin is being used by the gut, and it's produced on the order of 400 times greater amounts than we see produced from the pineal gland. So it seems
We
to
have to
have
stop there for a second. You just said that the amount of melatonin produced in the gut can be 400 times greater than that put out by the pineal gland. Wow.
exactly. So there's but I don't think we should look at the quantity per se. It's really about the quality and where it's used and why. So the pineal gland is circulating melatonin throughout the body in order to, again, to regulate these clock genes within us. So yes, I mean, I think that we're going to find out more about the gut brain interface and how the gut potentially is cross-talking with the pineal gland. But from what I can see from the literature, I do think that it's used locally. One of the biggest organ systems in which melatonin was actually discovered is the skin. So
Mm.
melatonin means skin whitening. And that's one of the connections, as I see it, between vitamin D and melatonin, is that they're both inherently found in the skin. So, we can be asking the question, well, why is melatonin in the skin even? And how is that function different than the gut? How is that function different than the pineal gland melatonin? So, I do think that there are these functional signatures of melatonin that we see throughout our physiology. So, it can be very diverse.
Well, throughout your paper, you really did draw comparisons with vitamin D, saying melatonin is the hormone of darkness and vitamin D is the, call it a hormone, I will, of lightness, of light exposure,
Hmm.
and that
Hmm.
there's a very strong overlap between what they end up doing. In fact, you had a wonderful graphic. Why don't we turn to that graphic right now?
Yeah.
And
Yeah.
maybe you could just walk through what we're looking at.
Okay. So did you, I can bring it up. So essentially in the paper, what I did was I created this graphic. It's like a Venn diagram between vitamin D, which is on the left as the biological light sensor, and melatonin on the right as the biological dark sensor, and they both have their colors. In fact, I liken vitamin D to the brother and melatonin as the sister. It's like they're brother and sister, that they really do regulate our circadian rhythm, or at least connect us to light and the circadian effects of light. So if we look at the shared functions, and we wrote this paper for the Nutrients Journal, and I began to even think within my nutrition science mind that, well, perhaps vitamin D is, sharing these functions kind of in an inverse relationship way with melatonin, and perhaps melatonin is actually a nutrient that we need and that levels go down over time. But if we don't have them, much like vitamin D goes down over time, then we start to see implications in a wide array of different functions. So some of those shared functions, which people will see in the paper, and I have a table as well, is looking at, of course, the hormone action. We know that vitamin D is unique in that it's also a hormone. They're also potent antioxidants. In fact, one of the things that I learned in doing this research is that one molecule of melatonin can scavenge up to 10 different reactive oxygen species. And that's very different than some of the other antioxidants like vitamin C or vitamin E. And not only does melatonin scavenge a lot of free radicals, we see that the plant based melatonin can scavenge even more. So there's something about the other constituents of the plant, of course, that are adding to that effect.
Well, and
Anti-inflammatory, immune modulating effects, all of these things really do go as part of that whole composite.
you indicated, in fact, you have several graphs in the paper. Right? People can look at that. Again, we're going to post a link to that, showing a variety of comparisons of the plant-based melatonin with the melatonin that we also similar to what we would produce, and it looks like it's far more effective in terms of at least antioxidant activity and perhaps even its anti-inflammatory activity, indicating at one point that it has COX-2 inhibition activity. Now, I don't mean to be too technical, but we know there are a bunch of medications on the market that function by inhibiting what's called the COX-2 enzyme. Celebrex, for example, they are called COX-2 inhibitors, and in fact, aspirin has some of that activity as well. But here is a powerful indication that at least phytomelatonin has some pretty darn profound anti-inflammatory activity. If you want to be specific, through that pathway. So, again, getting away from just the notion of helping me go to sleep at night. You mentioned antioxidant activity, and maybe we'll talk about the pro-oxidant activity as well, but powerful, seemingly anti-inflammatory activity.
There is, absolutely, which is why it's been brought into looking at things like cancer, looking at chemo prevention. But yeah, just in terms of comparing phytomelatonin to synthetic melatonin, there's a dramatic difference. So 646% greater activity as it relates to its anti inflammatory potential, which is huge. So I do think that one of the reasons for phytomelatonin outperforming synthetic melatonin is because of all of the different agents that it contains. Not only does it contain the bioidentical melatonin, but it also contains the beta carotene, the chlorophyll, even lutein and zeaxanthin, which can help to be protective for that artificial blue light in the retina. So I do think, one of the things that came out for me when I was doing this paper was I had no idea that most of the melatonin on the market is synthetic. So about 99%. And we did do some data crunching in terms of looking at the number of products, how many of them were phytomelatonin, and it's not very common that you find phytomelatonin in supplement form. And even some of the phytomelatonins that are out there can be chemically synthesized. Maybe they start from a plant, but then there is incurred in the chemical processing other types of substances. So I had no idea. I teach environmental health for the Institute for Functional Medicine. We just got off of the module talking about toxicants, but the idea that you could have up to 13 different adulterants in synthetic melatonin to me was very concerning. And one of those adulterants is serotonin.
Concerning, but probably not really surprising, when you realize when you finally analyze a lot of the stuff that people are consuming, you realize that
Mhm.
primum non nocere, above all, do no harm, and also caveat emptor, buyer beware. But that said, I think your typical consumer is perhaps mostly unaware of a lot of the stuff that you have already mentioned. That
Mhm.
melatonin at the health food store is something that is purveyed to help you get to sleep at night. And again, I promise we'll get to that because I know our audience really wants to know, should I be taking melatonin at night? And maybe as an entree to that or segue, we can talk about that people my age might well have pretty low melatonin levels. In fact, from puberty on, melatonin levels seem to decline pretty precipitously. I think there was an indication in your paper that it may mirror or be perhaps a surrogate marker of chronological age, or at least biological age, let's say. That with time our melatonin levels decrease, and perhaps that's an indication that we should consider doing what we can to keep our melatonin levels higher now that we know that immune function is involved. Inflammation, we mentioned antioxidant activity well
Mhm.
beyond sleep. Not that sleep isn't important. So, how do we think about the fact that from puberty on, our melatonin levels are in pretty much a steep dive?
There is this precipitous decline that happens from the age of about 20 on, and we start to see those levels bottom out at about 55-ish, depending on the person.
That
So
was a while
indeed,
ago
there's
for me, 55.
well, and
So
it's
at least
coming
I've
down
leveled
over
off.
time, right? Yes, and it bottoms out truly between 60 and 70 is what we see. And there are a number of studies looking at the role of melatonin and aging, markers of aging, which we know are influenced by the mitochondria. And in fact, alongside of all of the data on sleep, we see this whole repository of literature just focus on the use of melatonin in those particular functions that you mentioned for aging. So, as an anti-inflammatory, helping to collect all of the free radicals to scavenge them, and overall as a mitochondrial regulator. Within the cellular organelle, the one organelle that contains the most amount of melatonin is the mitochondria. And I do think it has to do with the amount of oxidative stress that the mitochondria is undergoing. So it's constantly experiencing a lot of output through metabolism, creating these oxidative bursts. And so the melatonin is that yin quieting, quelling, it's absorbing a lot of those reactive oxygen species. So, and that's why, melatonin works very well with vitamin D if you think about it, because throughout the life cycle, we actually decline in our vitamin D levels. We decline in our immune health. We decline in our inflammatory um, cascades. Like we're not able to clean those up fast enough. And we know of that, the inflammaging that occurs just through the life cycle. So I do think that we have to think about replenishing melatonin and being a bit more proactive with it as we move into those later
Let me
years.
just open this up a little bit more for our viewers, just to get their arms around where we're going with this. And that is that, central, one of the central ideas on aging is that our mitochondria, our energy producing organelles within every cell of our, almost every cell in the body, not erythrocytes for now, but that they undergo progressive decline in function, making less energy. And why that matters is obviously from the energy perspective or utilizing less energy, but also when mitochondria are less efficient at utilizing energy, it can activate a program within them that signals them to commit suicide that we call apoptosis. So these changes in energy levels can ultimately lead to mitochondria, leading to the cell actually dying. We said that in the brain. We call this activation of caspase enzymes, and ultimately the cell dies. And certainly you don't want to lose brain cells. But that said, so we become really kind of involved in the importance of mitochondrial function as it relates to tissue degeneration and overall body aging. And we know that things like regulation of inflammation depends ultimately, to some degree, on functionality of the mitochondria. And We even now recognize that in the brain, there are some subsets of an important type of cell called microglia that seem to be exquisitely sensitive to the variations in
Mm,
functionality in the mitochondria rather. And therefore, anything that can upset mitochondrial function is something we need to pay attention to. I'm not saying we need to target it, but at least should make us aware. Now, you brought to our attention a probable central role that melatonin is playing in keeping the mitochondria functional, because the mitochondria are the furnaces where this fuel is being basically burned. We want to keep, we want to contain the free radicals, the oxidative stress that are the byproducts of this metabolism contained, in other words, quenched by having good antioxidant activity. Melatonin, surprisingly for all of us today, is a
mm.
powerful antioxidant doing that job. And its decline with time might be a reason that mitochondrial function and safety and quenching of free radicals declines with time, which has been thought to be sort of a central one of the central tenets of aging. So this contextualizes your paper on this facet of melatonin in a very important light, because this may be one, everyone wants to say, oh, this is the central theme of aging. We won't go there for now. We know there's a lot of things involved, but this is really important stuff. We didn't know this about melatonin. And gosh, it's really enlightening that you share that perspective. I don't know that you fully unpacked it like we are doing right now, but it's as Jeff Bland would say, an aha moment, isn't it? That we embrace melatonin in this regard.
Well, you connected a lot of dots there. You brought in the brain, the aging aspects, the mitochondria, so going from macro to micro. When I look at the mitochondria and how it responds to melatonin, it is selective for melatonin, and I think that it's in part because the melatonin molecule can do so much to clean up those free radicals. As we get older, we are, as the saying goes, we're getting rancid. We are producing a lot of these free radicals. This came out in the 1990s. A lot of work on anti-aging medicine involved these free radicals, and what we see is that the mitochondria, even if you look at the melatonin as a molecule, even its metabolites can serve as antioxidants. So I find that very profound. And one thing that you might find very interesting, Dr. Perlmutter, is that even within the brain, so if we look at the glymphatic fluid, what we're now seeing that is coming out in the research is that maybe melatonin is responsible for being very active within the glymphatic fluid, removing that metabolic waste, really moving that through in a way that is cultivating much more in the way of metabolism at the level of the nighttime when it's very high. Perhaps that's one of its functions. Now we don't know that for certain because right now what we see is that there's just more in the way of animal studies, but I feel like there's probably a connection there. A lot of our nighttime activities, whatever we're doing at night, may in fact be connected into the functions of melatonin.
Now, mitochondria are able in some way to induce melatonin production based, one would think, upon their need or their desire. I won't say their desires, although I just said it. But mitochondria are actually able through various channels to actually enhance the production of melatonin. How does that work?
As far as when it's almost like when the cell is undergoing a lot of oxidative stress, it can start to induce certain enzymes, these antioxidant defense enzymes, in order to enable the cell to better modulate the oxidative radicals that are coming about. So there can be this induction through the reactive oxygen species that the mitochondria are producing. So the body is trying to protect itself, it's trying to regenerate, it's trying to accommodate. Now, that can happen within a certain threshold, but if the mitochondria are overloaded, then we get into dysfunction. So that's why I think pulling in exogenous melatonin could be important for mitochondrial health and dysfunction long term. One of the things that I found of interest, and I was sharing some emails with Dr. Terry Walls, was that we see that melatonin is even being used in autoimmune conditions like multiple sclerosis. There's some exploration in that particular area. So that's again speaks to me of okay, if we're starting to look at the chronic conditions that tie into mitochondrial health, bringing in things like melatonin might be of benefit. So, we see that across the board reproductive health issues, gut concerns like IBS or even GERD. We're starting to see that melatonin can span many different body systems. And I think based on what we're talking about here, one of the common threads or the links might actually be the mitochondria.
Well, there's a lot of correlation here, isn't there? I mean, we see a dramatic correlation, as mentioned earlier, of melatonin levels declining as we age. We see a correlation with this decline in melatonin levels with declining uh, uh, physiology, declining multiple parameters of functionality, and certainly even mitochondrial function. So that the sense is then, well, maybe there's a relationship here. Do we take that next step then and make a recommendation based on science, what we're able to determine today, that perhaps it's reasonable to supplement melatonin, especially phytomelatonin?
Well, I think well, let me ask you, do you take melatonin based on your
I
knowledge
do.
of
I
you
do
do?
from time to time.
Okay. Well,
And
that's
I
good.
will
That
tell you that, though I'm not taking it lately, and I'll tell you why. And I can thank you for that. I'm not thanking you, but blaming you, thanking you. In your paper, you talked about rebound, and you talked about taking how some people taking melatonin will awaken later in the night and can at times have difficulty going back to sleep. And that was happening to me. But now I've understood where that's coming from, and I'll tell you about that in a moment. So I had been taking 2.5 milligrams a night, sublingual,
mm,
and but and then I fall asleep within about 90 seconds anyway. My wife will tell will tell people that because it's kind of distressing for her. But nonetheless, I was taking it based upon reports like yours that there may be some immunological upside, et cetera.
mhm, mhm.
But with that middle of the night awakening, I backed down off melatonin in the past few weeks. But then I understood what was causing my awakening in the middle of the night. It had to do with eating too late. And
Ah,
so
okay.
I've
Did you
changed
find
that.
that out
And I've
from
known that for
uh-huh.
years. But I eat less and I eat earlier, and I'm really happy with my sleep now. But no, I've been taking melatonin on and off for a long, long time in general, and also I've really depended on it for jet lag. But I think that's a simple discussion. We'll get to that later. But we'll back it up to what are your thoughts then about is there an upside for people like you asked me, people taking melatonin?
Yes. So let me talk about that a bit because I do think that there can be a number of proactive steps that we can make in that direction. Because, people have a lot of concerns about melatonin. It seems like it's always in the news. That was another reason why I wanted to write this review paper. For
I love your
aging
curiosity. I think it's great.
well, and it won't stop. I'm continuing to look at melatonin in a variety of different ways. Especially cancer. Cancer is very intriguing to me, especially with the rates of cancer going up, toxic burden on the planet. So,
Sure.
I
And autoimmunity as well. I mean, the fact that you
autoimmunity,
interact with,
absolutely,
yeah, Terry
absolutely.
Walls, MS, that whole, I think there's a huge opportunity. So, what should the common person be thinking now?
Yeah. So if we think about hormones in general, so I liken melatonin, if we're just having the discussion about getting back to replenishment, thinking of things like estrogen, progesterone, testosterone, thyroid hormone, where we have a depletion and we need to go back into replenishment. How do we get back our biological levels? And this is where the question of dose comes in. What is the actual physiological dose? So in the paper, we have as we were just talking about a little while ago, we have the curve showing the levels that we typically see associated with different age groups. And if we look at replenishing our levels, the amount of melatonin that we would need supplementally is actually quite modest. And some of this work comes from Dr. Richard Wortman and others at MIT. This is early research going back a bit, showing that a physiological dose of zero point 0.3 milligrams actually outperformed a higher dose, a pharmacologic dose of 3 milligrams. So I don't think that more is necessarily better. I think it's about finding the sweet spot and personalizing the dose to the individual. Now, that's a physiological dose, zero point 0.3 milligrams, as something to have to replenish the levels that we lose with age. Now, if there are certain instances, like somebody does shift work, or they have jet lag, or they have a certain profession where they're subject to a lot of dysfunction in their circadian rhythm, then that might need to be adjusted. But I think that for the most part, if we're just trying to fill the gap, looking at zero point 0.3 milligrams. Now, one of the things that leads to some disruption or side effects, or when people say, oh, but I feel dizzy or groggy, or, I had vivid dreams when I took melatonin. If you look at melatonin and how it's processed through the body, what are the metabolism features of it? So it does go through phase 1 and phase 2, liver detoxification. And for some people, yet primarily for some of your viewers that are aware of the cytochrome systems, it does go primarily through cytochrome P 450
450.
1A2. 1A2. So for some people who are fast metabolizers, they may actually be processing it quickly. So, and that's very similar to caffeine, where some people, like myself, I can drink a cup of coffee and have absolutely no effect from the caffeine. My body just metabolizes the caffeine quickly. So, in the case of melatonin, there can be personalized kinetics of how somebody does process it through their body.
Is there a concern that you will induce that cytochrome P450 enzyme system by taking melatonin more and more and then become in a situation that you really need it?
I don't I'm not sure. People do get concerned about endogenous production. There's no data to suggest that taking melatonin can change endogenous production. I do think that we might be changing receptor activity, much like we might be changing receptor activity with other exogenous hormones. So we might sensitize those receptors, we might saturate the receptors. So there may be some implications there that we might postulate just even from people's clinical experience. But if I look at Dr. Paolo Lissoni's work, and this was back in the 1990s, he used high dose melatonin for his patients going through chemotherapy. And he did not find any kind of side effects related to even high doses. And we're talking about very modest doses. I'm talking less than 1 milligram. So I don't think that we create a dependence per se. I think that again, your body is just primed to make melatonin. It's going to do whatever it can. All the different organs, all the different tissues, we're getting it in our foods in very small amounts. So I don't think that in that particular way we create any kind of a situation where we're going to need more and more. I think overall, it is something that our body needs. And so if we're low, yes, we're going to need to fill that gap in some way.
There were protocols that I had seen where 20 milligrams per day were being prescribed when a person was suffering from COVID-19.
Hmm.
I don't know. I don't think the outcome studies demonstrated any efficacy, but that's a pretty large dosage. So, the reason I bring it up is it does show a fairly large safety window, doesn't it?
It does, especially with short term use. I don't think we know about long term use, but if you look at Dr. Lissoni's work, when he was using it with his patients with cancer, they were going through chemotherapy. It actually made them more able to have the chemotherapy work better. So it was promoting the body's response and enabling better effects, and also less side effects of the medication, and overall better sleep and some of the other aspects. But again, that was short term use and in conjunction with certain therapies. So yeah, with COVID-19, using it for short term use alongside of things like vitamin D, zinc, vitamin C, this has been explored. And again, that was part of what piqued my interest to really explore melatonin.
Um, I would say that the notion of melatonin in conjunction with, for example, on a chemotherapeutic protocol, plays well with the notion of this chronobiology that our immune systems
Hmm.
function differently in the day when we're awake versus at night. And we do know on longstanding research that indicates that the time of day you receive chemotherapy has a bearing on whether or not it's going to work really well or not, I mean, or may I say efficacy. And understanding that, then we would tend to think that then a chronobiomodulator like melatonin might then have a role to play as it relates to how our immune systems are working. You've drawn quite a bit of comparisons and parallels with vitamin D and how they may work antagonistically, but may work synergistically as well. And how interesting it is that melatonin can bind to the VDR, the vitamin D receptor.
Yes.
What that might tell us if melatonin, which in many ways being the hormone of darkness versus vitamin D, the hormone of light exposure, why what are we to imply then from the fact that melatonin can bind to the vitamin D receptor?
So it's encouraging this signal of vitamin D through the cell, and if they're working together, kind of the yin and the yang of circadian rhythm, then it might make sense that again, melatonin is like this mother molecule to creating amplification of effects in the body. And again, back to where we started the conversation, melatonin is even able to do this within plants. It's a growth factor within plants. A little bit differently than in humans and not always connected to the circadian rhythm. But I do think that what melatonin is doing is it's essentially creating greater amplification of vitamin D's all the many effects, the pleiotropic effects of anti-inflammation, antioxidant, immune benefits. So I do think that both of them together are encouraging for us to be thinking about, especially in the later years.
Well, my mind was drifting, and I apologize because I was thinking about plant auxins and things like indole
Hmm.
acid that are light sensitive that explain why sunflowers are able to follow the sun because the growth is inhibited on one side and enhanced on the other side in the presence in with these chemicals being present that can be inhibited in their functionality by light, and that's
Hmm.
how the sunflower can track the sun. And we know that melatonin similarly is inhibited in its production by light. You talk about darkness deficiency, I think your term, and why is that something we should be paying attention to?
Well, if we think about the nighttime and the activities that people are doing at night, and I think that there was a study back in 2015 saying that 90% of adults had light at night, or what is referred to in an acronym as LAN. So there's a lot of artificial light exposure during the nighttime when we should actually be having more of the darkness and not trying to change our environment in such a way to keep us up late at night, to keep us on screens, to keep us on devices. And so what's happening as a result of this extra light at night of the blue light variety is that it's changing the signal to the retina, which is leading to reduced production of melatonin by the pineal gland. Again, the only way that we're able to make that pineal gland derived melatonin is in the darkness, and that's when we produce the most, is when it's most dark. So I would say that much like vitamin D has been associated with sunlight, and people say, oh, you just need to be out in the sun, you need more UV light exposure, even small amounts, certain amounts per day. I think we need to be thinking about melatonin in the same way that we need darkness. We need both of them. Both of those two together create the entire circadian rhythm balance. And I do think that we're
Well,
going to see more.
how big of a deal
Please.
is it in terms of the amount of melatonin? Let's say if an individual from 8 p.m. on is exposed to total darkness, X amount of melatonin, and then that individual, let's say, is up watching Ozark or whatever it may be, or on his or her computer. My wife's going to love it when she hears this because she's telling me not to. But anyway, what is the effect then? What would you guess is the effect on your melatonin production, melatonin levels? Because you didn't adhere, I didn't adhere to your advice. How low will how much will my melatonin levels be affected by that maneuver? So the question I'd like to ask you is how much would a person's melatonin levels be affected if they were to compare going into total darkness at 8 p.m. and then waking up the next morning versus doing what a lot of people do, and that is watching TV on the computer at night prior to going to bed at 10 or 11 o'clock and having actually that blue light exposure? How dramatically does that affect melatonin levels?
Well, it's dramatic. Of course, it depends on the individual and the amount of sleep that they normally get, the amount of melatonin that they normally need in order to have that good, healthy night's sleep and circadian balance. But in general, most people are getting way too much in the way of that artificial light at night close to bedtime. So there's no lag between having the darkness, having kind of this easing into bed. It's some people are even taking their phones into their bed. And so there isn't this gentle progression of creating more melatonin in order again to help with healthy sleep. And I think that's what we need to look at, especially with children. Children produce the most amount of melatonin. If we look again at the life cycle, but yet, I see that there's some awareness around taking melatonin supplements, having kids take these gummies. But I do think what we need to be doing is having less in the way of that light stimulation from television, computers, kids on devices. But I do think it's dramatic. And over time, we start to see that we start chipping away at that level of melatonin that we need for good, healthy sleep. So it's something that we
I
have to be
think this
looking at.
regulation of the regulation of our circadian rhythm is so incredibly important. Dr. Satchin Panda has made that so clear that whether we're talking about something as maybe straightforward as weight loss, which seems to be a goal of everybody, but even more important, considerations like immune regulation as it relates to day to day immunity, but also in terms of cancer surveillance and even cancer treatment, and certainly inflammation balance. That this maintaining a good circadian balance so your body knows what to do and when is really critical. And, certainly a fundamental mediator of that process seems to be melatonin. So, this is a work in progress, isn't it, amongst many researchers?
It is. And I'm so glad that we're waking up to this cycle of light and dark.
No pun intended.
We're becoming more
Or
enlightened,
waking up
right?
to light.
We're waking up to it. And,
Yeah, I always knew you were bright anyway, so I don't I don't explore the dark side.
well, one of the things I would like to see, even from a laboratory perspective, is perhaps connecting to the clock genes. Is there a way to assess individualized variability, so gene variants in clock genes, and how we might be able to get a little bit of a window into what's happening at our personalized organ system level, so that we can better regulate these many different hormones. And I think that ancient traditions have been keyed into this for some time. We look at Ayurveda, we look at traditional Chinese medicine. There was always a system of organs and times when they were most responsive. So I think in the future, we're going to have metrics, we're going to have devices, we're going to have gene variants that may coincide with our circadian rhythm to give us better visibility into perhaps dosing of things like melatonin, or even looking at the interrelationship of all of the hormones. Because one of the things we didn't talk about is how melatonin at night, but then cortisol, testosterone in the morning hours. So, there's this whole cycle of hormones that are all playing together. So, if we tug at one and we're constantly up late at night on our devices and we're tugging on melatonin, then chances are we're going to be disturbing the spider web of other hormones, things like cortisol, testosterone, estrogen, etc.
Which we can't necessarily afford to disrupt. It's quite clear that our evening sleep hygiene has a huge role to play in the quality and quantity of sleep that we get, as people are now measuring with their various wearable devices, like an Oura Ring or whatever you may have. And I think people are beginning to get the sense that they have control over the amount of REM and deep sleep that they get, and then understand. For example, you mentioned earlier the functionality of the glymphatic system, or allowing the brain to clear itself out and how that might relate to melatonin levels, which it may very well. But I think people are becoming more astute in understanding what their personal response is
Mhm.
to staying up and watching Ozark or whatever it may be. Why do I say that? We'll leave that for another conversation. But whatever, whether it's eating later, which was something that was an issue for me, but it gives us the ability to determine how does it affect me. Yes, it's great to know what my genetic polymorphisms are as they relate, in this case, for example, to the cytochrome P450 suite of enzymes that may involve degradation of melatonin. Therefore, why I might have too high or too low, or a higher than typical or low, whatever. So we're learning more about ourselves, and I think the future is going to be more complicated. But I think that we're developing the tools to
Mhm.
be able to get back to your statement, to look at multiple variables and see how they interact, to see what our AM cortisol level and glucose level, insulin functionality is, and relate that back to these factors over which we have control, and then pave the way for us to be better stewards of our health destiny moving forward. So great to see you as always. And, I'm most taken by your response to my first question, which was why are you doing this? And it wasn't about melatonin. It was just about the curiosity part. Because I get asked that question all the time. Why uric acid of all
Mhm.
things? For a
Mhm.
neurologist, why'd you be interested in gout? It's just that that's what makes it so fascinating to do the work that we do. So good on you.
Right.
And again, I'm going to direct everybody to your paper, which I think is fantastic. And I really appreciate spending time with you today.
Thank you. Thanks for the invite. It's always a pleasure.
Well, I hope that takes away at least some of the mystery about melatonin. I think it has value, as we learned today, even by virtue of the science that now surrounds it. But I think moving forward, with the amount of research being done, we're going to hear a lot more about melatonin. So stay tuned. Thanks for joining us today. I'm Dr. David Perlmutter, and I will be back soon. Bye for now, everyone.